Imagine one telephone operator trying to personally hold 15 million calls at once. That's what Discord servers do. Every second. In 2017, their entire system collapsed at just 1 million users. Today, they handle 15 times that load without breaking a sweat. Here's the switchboard trick that saved them. Discord isn't a chat app, it's a live nervous system. 19 million active servers. 15 million people connected at once. Messages, voice, and video delivered in under 50 milliseconds worldwide. Every one of those is a phone line that must stay open for hours. That's the real challenge nobody talks about. Normal web requests are stateless, like sending a letter, then forgetting it existed. Chat needs the opposite, a phone line that stays open for hours, for millions of people, simultaneously. Keep that line alive and route messages instantly. Get it wrong, and the switchboard melts down under its own weight. A standard Linux server chokes at 65,000 open connections. Send one message to a 100,000 member channel, and naive systems try to blast it out all at once, blocking everything. Restart a server, and every client reconnects simultaneously. 3 ways the switchboard jams before you even hit 1 million users. Here's what nobody tells you. Discord's first gateway was written in Python. In 2017, it hit a wall at exactly 1 million concurrent users. Not from bad hardware, but from the JIL, Python's global lock forcing every connection through one single thread. The whole switchboard froze solid. Remember the switchboard? Discord replaced one exhausted operator with millions of tiny ones. Elixir runs on Beam, the same runtime Ericsson built in the 1980s for telecom switches handling millions of calls. Every connection gets its own lightweight process. One crashes, the rest keep talking. One Java thread costs about 8 megabytes of memory. One Beam process costs 2 kilobytes, 4,000 times lighter. That's how a single Elixir gateway node holds 250,000 live connections. Discord runs about 30 of these nodes. That's your 15 million switchboard operators, always on duty. Here's the real handshake. Your client opens a TLS WebSocket to gateway.discord.gg. It sends an identify payload with your auth token. The gateway verifies it, spins up a dedicated process just for you, and sends back ready. Your servers, DMs, and presence, all in one shot. Now the harder problem. Presence. Knowing which friends are online, in real time, across millions of users, is Discord's hardest distributed systems challenge. Their fix, one Elixir process owns each user's presence, pushing updates only to the specific channels actually watching. No broadcast to everyone. Here's the counterintuitive part. When you open Discord, you don't get presence for all 500 friends immediately. You only get presence for who's visible on your screen right now. That single trick shrinks the initial payload from megabytes to kilobytes, and it's why Discord feels instant. Every message you send has to be stored permanently at massive write volume. Discord chose Cassandra, a database built for write-heavy workloads with no single point of failure. Messages are partitioned by channel ID plus a 10-day time bucket, so scrolling through history stays fast at billions of rows. The numbers are staggering. 177 million messages a day, about 1 terabyte written daily, and just 12 Cassandra nodes handling all of it, each message replicated 3 times for safety. No single server failure can lose your messages. In 2023, Discord migrated billions of historical messages to ScyllaDB, Cassandra compatible but written in C++ instead of Java. Result: P99 read latency dropped from 40 milliseconds to 15. Infrastructure costs fell by 53%. Same data model, faster and cheaper by cutting out the JVM entirely. No single machine can hold 15 million connections. So Discord shards everything. Each server or guild routes to one of about 1,000 gateway shards based on a simple formula on the guild ID. Each shard handles roughly 15,000 connections, its own mini switchboard, independent of all the others. Voice is worse. In a naive 50-person peer-to-peer call, everyone sends 49 separate streams. Discord's fix, a selective forwarding unit. Each user sends just one stream up. The SFU server routes only the correct streams back down. One upload, many smart downloads, not an all-to-all mesh. Discord rewrote their SFU from Go to Rust. The payoff: 35% less CPU usage, and garbage collection pauses eliminated completely, because Rust has no garbage collector. For real-time voice, a 200 millisecond GC pause is the difference between smooth audio and stuttering static. Hitting Cassandra every time you scroll would be brutally slow. So the last 50 messages per channel live in Redis. ready in microseconds. Only on a cache miss does Discord fall back to Cassandra and refill the cache. Redis handles roughly 3 million operations per second across the fleet. Now here's a detail most tutorials skip: keeping millions of WebSockets alive. Clients send a heartbeat every 41 seconds. Miss too many, and the gateway assumes you're dead and drops you. On reconnect, a session ID lets you resume exactly where you left off. No refetching your friend list. Zoom out, and here's the full stack. Cloudflare routes you to the nearest edge. Elixir gateways hold your connection. Rust powers voice routing. Cassandra and Redis handle storage and speed. 4 specialized layers, each doing one job extremely well, instead of one Python monolith trying to do everything. If you built this in an interview with 1 thread per connection and a single database, you'd hit a wall at maybe 50,000 users. Discord's actual design. Lightweight processes, pub/sub fan-out, sharded storage, is what separates a class project from something that survives 15 million real humans. Discord isn't alone in solving this. Slack serves 32 million daily users with Java, Netty, and Kafka instead of Elixir, because enterprise customers need strict data isolation. Different constraints, same core problem: keep millions of stateful connections alive and fast, worldwide, under 50 milliseconds. In your next system design interview, say exactly this: persistent connections need process per connection isolation, not thread per connection, because threads don't scale past tens of thousands. Then cite Discord's 2017 Jill collapse as real-world proof. That one sentence signals you've actually thought about this, not memorized it. 8 years, 4 major rewrites, 1 obsession. Never let one bottleneck decide the ceiling. Python to Elixir for connections. Go to Rust for voice. Cassandra to ScyllaDB for storage. Every migration targeted the exact layer about to break. A surgical fix, not a full rewrite. 95% of Discord's database traffic is reads, not writes. History, scrollback, search. That's why the Redis caching layer matters so much. Get your read path right, and your expensive database barely notices the 15 million people hammering it every second. Strip away the brand names and 4 principles remain. Isolate every connection into its own lightweight process. Shard everything: gateways, databases, even oversized servers. Cache your reads, replicate your writes. And when something breaks, rewrite that one layer, not the entire system. Discord, Slack, Twitch, Telegram, WhatsApp, completely different products, same underlying problem. Millions of persistent connections that must stay alive, in sync, in real time. Learn this pattern once, and you can reason about all 5 architectures. That's the real leverage of studying system design. Discord didn't invent a new switchboard. They gave every caller their own tiny, indestructible operator, built on tech from 1980s telecom. That's the whole trick. Isolate, shard, cache, repeat. Subscribe for the next teardown, where we open up Netflix's recommendation engine.